So, in the previous video, I have formulated the Hamilton's equation where you got this pi dot equals to del h by del qi dot equals to del h by del pi, which are known as Hamilton's equation in the motion, and you also got the del h by del t equals to minus del l by del t. Okay, now I'll show you that if I have provided you a Lagrangian, what will be the form of the Hamiltonian? Okay, it's quite interesting thing and it is mentioned in the question. It is very interesting thing. So let's say I have given you a Lagrangian. Okay, it is a function of q dot and time t. Okay, from here if you want to write down the q dot, what is the q dot? Or qi dot is equal to del l by del, sorry, from here if you want to write down the pi, this is equals to del l by del qi dot. So your pi is initially function of q dot on time t. Okay, because after differentiation you will get something like that. Pi is a function of q dot on time t. Okay, so your Hamiltonian is what? Hamiltonian is a q dot p minus Lagrangian. Okay, and is a p is a function of q dot and time t. L is a function of q dot and time t. That means initially your Hamiltonian will be also function of q dot and time t. But you have to go to Hamiltonian form, which is function of q, p, and t. So how you can get this? You already got the relationship that p is a function of q dot time t. If you somehow get the q dot, I mean you can invert this relationship and get the q dot as a function of q, p, and t, then then your problem is solved. After that, if you put the q dot as a function of q, p, and t, you'll get this Hamiltonian as a function of q, p, t. The meaning of inversion means, let's say y is equal to your xy, sorry, y is equal to xz. Okay, so from here you can easily write down the z is equal to what? Y by x. I'm just giving a simple example. So when y is a function of x and z, from here you can easily write down the z as a function of y and x. That's how I'm trying to say that pi is a function of q dot t. If you can invert the relationship in such a way, somehow that you get the q dot as a function of q, p, and t, then your problem is solved. So this is the main idea, that you have to find out the q dot in the form of q, p, and t. If you can do that, you can easily write down the Hamiltonian. So just the thing is that now, before going to the general form of the Hamiltonian in almost in general problem, okay, so let discuss about this Lagrangian general form. In most of the system, when the system is holonomic system, and and almost in many system you can write down the Lagrangian is L0 plus L1 plus L2. What is L0, L1, L2? That means you can write down the Lagrangian in such a way that there will be a part which is just a function of q and t. Okay. There will be another part. There will be another part which is a function of another part which there is a coefficient part which is a function of q and t with multiply with the some generalized velocity. Okay. Okay, and there will be another term, okay, where there is another coefficient that is a function of b. There is another function, let's say this is a function of q and t, and here the generalized velocity is not in the single form, it is a quadratic form. Okay, So qi qj dot I and j summation, there is I summation. Okay. So the fact is that you can write down the Lagrangian in this form in many problems. If you can write down the Lagrangian in the form, you can write down the Hamiltonian. What is Hamiltonian? Hamiltonian is your qi dot pi minus L. That means your qi dot del L by del qi dot minus L. And if you do that, okay, this calculation, there will be summation over I qi dot. If you do the del L by del qi dot, okay, from here you can easily get ai is a function of q and t, and from here you will get some bi and your qj dot with the summation over j. And if you again sum over it, that will become, and then there will be some two term also, there will be some two term also. Okay, because when I and j equals to same, then there will be just a q1 dot q1 dot. If you differentiate with the q1 dot, you'll get some two term here, because this is q1 dot square. So you'll get two term here. So that will becomes qi dot ai, that is nothing but your l2, sorry, l1, that is nothing but your l1, and plus 2 times q1 dot qz dot bi, that is your l2, 2 times l2 minus l is your l0 minus l1 l2. So that will cancel out, you eventually get l2 minus l0. So your Hamiltonian is nothing but your l2 minus l0. That's all. So now look into this matter, that is quite interesting, that I can write down the L2 instead of this form, in this form, that L2 I can write down half times summation over ij, instead of bi I am putting down, so half summation over ij tij. Okay, and qi dot qj dot. Here again it is quadratic form, so I can write down this in this form. Okay, I'm writing the L2 in this form. Okay, I'm writing down the L2 in this form. Okay, and so now your L equals to what? L0, this is a function of q and t, plus summation over ai qi, and plus half times I comma j tij qi dot qj dot. So this is a multiplication. This is nothing but, if you, let's say there is a I and j are going from 1 to 2. Okay, I mean there is only two generalized coordinate, then I will be what, 1 to 2, and j will also from go 1 to 2. Then L will be what, L equals to L0, that is a function of qt, plus a1 q1 plus a2 q2, plus half times t11 q1 dot q1 dot plus t12 q1 dot q2 dot plus t21 q1 dot q2 dot q1 dot and t22 q2 dot q2 dot. Okay, so you can easily write down this in a matrix form also. There's a matrix a1, you can easily write down this as a matrix form also. Also there's a q1 q2, the row matrix, multiply with the a1 a2. Easily write down this. And I also write down this thing in this matrix form, that q1 dot, sorry, there will be dot. So q1 dot q2 dot, okay, that is multiplied with the t11 t12 t21 t22, that is multiplied with the q1 dot q2 dot. If you do that, you'll get this whole thing from here, multiplication, and you'll get this from here. So if I say this matrix q1 dot q2 dot, okay, as a q dot matrix. If I say this is a T matrix, then it will be what? This is the q dot transpose, and q dot transpose I am writing down q dot tilde. Okay, so this is what? This is your q dot tilde, and this is your A matrix. So what is the L? L is equal to L0 qt plus your q dot tilde A, where q dot is a matrix of q dot is a matrix of q1 dot q2 dot, and when there is a I'm talking about the two generalized coordinate. When there is n generalized coordinate, then q dot matrix will be q1 dot q2 dot q3 dot dot qn dot of the, okay. And there is a matrix. A is a matrix. How you can find out the A? When you are writing the L, there will be some. Let's say we are writing the in the Cartesian. Let's say L equals to something plus a1 x dot plus a2 y dot plus a3 z dot plus something like that. Okay, so the x1 dot has some coefficient, that is the a1. So you have to write down the coefficient of the all the generalized velocity term in the matrix form, that will give you the a1 matrix. And this is your half times q dot tilde t q dot. Okay, so we can write down from the summation to the matrix form. Now these are t matrix, which I already written out as the L2. Okay, this T matrix is a symmetric matrix. So Lagrangian is T minus V, right? So T is kinetic energy term. In the kinetic energy term, in general kinetic energy term, there you got something q1 dot q2 qz dot term. Okay. So basically, Tij is somehow connected to the kinetic energy term. Okay. So that's why the Tij should have to be symmetric and the real. Okay, because kinetic energy cannot be imaginary. Okay, so Tij is symmetric and the real. That means your T21 and T12 is same. That's I wanted to say that T21 and T12 is same, or if there is some n number of coordinates, then your Tij equals to your Tji. That's my whole purpose of saying. So you got the Lagrangian. You got the Lagrangian, right? You got the Lagrangian. Okay. Now you have to find out the Hamiltonian. Okay. So now you have to find out the Hamiltonian. It's quite easy because you got the Hamiltonian is what? Hamiltonian equals to L2 minus L0. So write on the L2. This is a L2. So half times Q dot tilde T Q dot minus L0. Okay. So this is your Hamiltonian. This is your Hamiltonian. But the main problem comes again here. You have the Hamiltonian as a function of q dot. L0 is a function of q and t. Okay. So you're getting the Hamiltonian as a function of q, t, and q dot. But you have to get the Hamiltonian as a function of q, p, and t. So now you have to find out, can you get the can you write down the q dot as a form of the p and t or q something? Okay, can you do that or not? So there is a Lagrangian. Okay, what is p? What is p? So just write down in the details in the detailed way. So again, I am talking about the two generalized coordinates so that you can visualize it. So L equals to L0. This is a function of q1, q2, and t. This is qt plus this is what? This is your q1 dot a1 plus q2 dot a2. Okay, plus half times t11 q1 dot q1 dot t12 q1 dot q2 dot plus t21 q1 q2 dot q1 dot plus t22 q2 dot q2 dot. So now find out what is your p1. What is your p1? P1 is equal to del L by del q1 dot. Okay, that will give you a1 and From here you will get some half times 2 times T11 Q1 dot, and from here you will get T12 Q2 dot plus T21 Q2 dot. Okay, and as your T12 and T21 are same, we can write down as a 2 of T12 Q2 dot. That will becomes A1 plus T11 Q1 dot plus T12 Q2 dot is equal to P1. Similarly, you can write on the P2. You can write on the P2. P2 is equal to A2 plus T of 21 Q1 dot plus T of 22 Q2 dot. So from here again you can write down the matrix. This is a P1, P2, P3 is a matrix which is nothing but a matrix A1, A2, A3. Let's say not take the 2 as you can you have to visualize it. Okay, so it's a P1 and P2 matrix. You can write down as a A1, A2 matrix plus your T11, T12, T21, T22 matrix that is multiplied with the Q1 dot and Q2 dot. You can write down this, and from here you can easily get down the p value. So you are getting the p value in this kind of value. So you can write down this is a matrix form. Okay, so from the and we can generalize it to the n coordinates. Then will be p1, p2 dot pn. Okay, okay, there will be a1, a2 dot an. Okay, plus t of 1 1 to the t of 1n to the t of n1 to the t of nn. Okay, and there will be some q1 dot to the qn dot. So now write down the matrix. This matrix is a p, so p equals to p matrix is equal to a matrix plus t times q dot matrix. So t times q dot matrix is your p minus a matrix. So what is a q dot matrix? It's equal to t inverse p minus a. Okay. So and go to the value age. So age equals to what? Half times q dot tilde t q dot minus l0. So I'm writing down this. What is your age? Age is equal to half times q dot tilde t q dot minus l0. So if your q dot matrix is this, what is the q dot tilde matrix and transpose matrix? If say C is equal to AB, what is a C transpose? B transpose A transpose. You'll get P minus A. The whole transpose is P transpose minus A transpose, and you're getting A transpose. And based on transpose, this is a T inverse transpose. T is a symmetric matrix. T inverse is symmetric matrix. So T inverse transpose is T inverse. Okay, just put down this value. So half times q dot tilde equals to p tilde minus a tilde into t inverse t times t times t inverse t inverse. Okay, p minus a minus l0. So your Hamiltonian will be equals to half. This will becomes 1 unity because t inverse t is equal to 1. So p tilde minus a tilde t inverse p minus a minus l0. So that will be equals to your Hamiltonian. So this is the general form of the Hamiltonian. In the next video, I'll explain this how you can formulate this with some examples. I'll get an example of center force field. I'll also take an example of the normal Cartesian problem, Cartesian coordinate problem, and I'll also take the problem of the motion of a charge particle in the electromagnetic field. I'll show how you can write down this Hamiltonian in this form. Okay.